All right, well, welcome. This time we're going to relate temperature to particle motion. And particle we can be referring to a single atom, or we can be referring to a large molecule. And it turns out that the concept of temperature, how hot or cold something is a reflection of how fast the particles are moving. So I have a couple water molecules that are here. And the first thing to realize about them is that they're always in motion. Okay, even in ice, okay, in really cold ice, you can keep lowering the temperature. As a solid, they're just wiggling in place. Okay, then as a liquid, they would be more moving by each other, and then as a gas, they're going all over the place, right? Okay, we were talking about that in the last one. So these particles are always in motion, and there's this kinetic theory of motion, and that's the beginning idea: is that all particles of matter are constantly in motion. Okay? The amount of motion varies, but they're constantly in motion. And we can say they have a kinetic energy, and that's energy as a result of that motion, as well as their mass. So more motion, higher kinetic energy, more mass. Maybe instead of this particle, it's this particle, more mass, or more kinetic energy. So more mass, more kinetic energy, more motion, kinetic energy. But what we really want to see then is that relationship of temperature. And as the kinetic energy goes up, either because you have more mass or higher motion, you get a higher temperature. Okay? So the temperature is a measurement of the average kinetic energy of the particles. And as they go from being slower to faster, that's a higher temperature. Or if we talk about a different mass of particles, this has more mass than this one, then it's going to have more kinetic energy and therefore a higher temperature. So if I look at my cup of coffee, assuming I drink coffee, that cup of coffee, the particles in there are moving much faster than they are when it's a smaller, or when it's a colder temperature. Those particles are moving slow. Okay? And in the cup of coffee, they're moving fast. And then size also makes a difference. And so if we have larger particles moving at the same speed as smaller particles, the larger ones are going to be hotter than the smaller ones. So one last time, same size particles, one's moving fast, and the other one, substance, they're moving slow. The faster moving one will be a higher temperature. Or we can have them moving at the same speed, but the larger particles would end up registering a higher temperature. We don't deal with this one quite as much. We're more interested in the same substance. We heat it up, we make the particles move faster, we get a higher speed or higher temperature off of it. Faster particles, higher temperature.